notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. These first 3 sections here, all 51 videos, have been published in their entirety on YouTube. From section 4, measurement, all 17 videos have been completed. 5 have been published on YouTube in their entirety. Section 5, statistics, all 18 videos completed. 5 of those have been published in their entirety on YouTube. Section 6, algebra, this is where we are right now. This is the 8th of 22 videos, and hopefully this section will be completed by mid-September 2025. Then we move on to section 7, relation functions and graphs, by October 2025. Then geometry, section 8, geometry and trigonometry, by November 2025. And finally, section 9, vectors and matrices, by the end of December 2025. Please note this disclaimer down here. This schedule is just a projection and it is not to be interpreted as a contract with anybody. Section 1, number theory and computation. There are 33 videos in this section, and all those 33 videos have been made available in their entirety on YouTube, especially since this section forms the foundation on which the rest of the syllabus is based. 33 videos. Please make sure you look at all of them and know them very well. Reminder, you need to know the times tables from 2 to 12, since calculators are not allowed in paper 1. Section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, measurements. These indicated in yellow here have been published on YouTube in their entirety, and the others are only partially published on YouTube. Please see direction in the description below for full access to these videos that are only partially published on YouTube. From section 5, statistics, 18 videos. These indicated in yellow here have been published on YouTube in their entirety, and the others are only partially published. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. We are at section 6, algebra, and this section has 22 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get especially more practice questions. CSEC recommends the following, shown at right here. Out of those, please pay close attention to these 2 below here, since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course with CXC Questions by Raymond Tulsi, and this is a picture of volume 2. Disclaimer, I get no financial or other benefits from the sale of these books. Also, very recently, late 2024 I think, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, and that is from paper 2. You can navigate by topics or years, where all questions for the past several years have been worked out. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page of that website looks like, which is this that you see here. First, you would have to register, and subsequent to that, you would have to sign in. This is that URL again, and that URL will be in the description of this video, so you can easily click on it and be redirected to this website. Another reminder, this formula sheet is provided for CSEC examination papers. Formula sheet you see here on the left. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have the complete syllabus, this formula sheet is in the syllabus. Take a closer look. This is the top part of that formula sheet. Note, you do not need to learn these formulae on this formula sheet, as this sheet will be provided during the math examinations. And this is the below part of that same formula sheet. And while you do not need to know these formulae, you do need to know when and how to use them. Overview of Section 6 Algebra. These first 4 objectives have been completed in these videos here, 4 videos. Continuing with overview, objectives 5 to 7 have also been completed in these videos here. Continuing with overview, we are now at objective 8, objective 8. And after that, we have some more objectives up to 16 here, which goes up to video 17, since we will have to split objective 14 into 2 videos. And then finally, we have to go up to objective 21, which is the end of section 6, algebra. And of course, those will be in these last 5 videos. So as I said, we have completed up to there. We are now here. These indicated by yellow have been published in their entirety on YouTube, and these others only partially published. When I finish this objective here, 6.8, which is video 8, this will be published in its entirety on YouTube. So as I said, we are now at objective 8, and we do have some explanatory notes. The objective itself says, simplify algebraic fractions. And the explanation here talks about the 4 basic operations on algebraic fractions. So simplify algebraic fractions. First, we will learn how to simplify single algebraic fractions. Then we will actually add, subtract, multiply, and divide them. This first part here, we have done it before, so it would be mainly review. Just to be clear, 0.75 is a decimal fraction, but it is normally just called decimal, numbers in this format. And 75% is a percentage fraction, but it is normally just called a percentage. format like this. Now, if it is formatted like this, 3 over 4, this is actually called a vulgar fraction, but normally we just say fraction, just to make sure we understand that all of those are fractions, except this format here, like 3 over 4, is normally what we refer to as fractions. So you already know the format of a vulgar fraction, as I said, 4 over 9, or 2 over 3. The number at the top is called the numerator, and the one below is called the denominator. If the numerator is smaller than the denominator, it is called a proper vulgar fraction, and if the numerator is larger, it is called an improper vulgar fraction. Don't worry about those terminology. You see fraction written like this, that is what we would normally call a fraction. So 4/9 and 2/3, let's add them. You know from section 1 that you will find the LCM, which is 9, and then you would divide that LCM by this denominator. So you say 9 into 9, you get 1, you multiply that 1 and that 4, and you get 4, you put it down here. You bring down that plus sign, and then you say 3 into 9, 3, 3 twos, 6. This is work that you learned way back in primary school, and we reviewed it in section 1. From objective 1.3, where it talks about add, subtract, multiply, and divide fractions. But these are typical fractions. Now we will be looking at algebraic fractions. So let us say you have 3a cubed over 12a. That is the fraction. We are going to simplify it. We have done this, as I said, in this same section a few videos ago. I will expand it so you could see exactly what is happening. 3a cubed is 3 multiplied by a multiplied by a multiplied by a divided by 12a, and then we will reduce a factor at the top with a comparable one below. Now, you normally say you cancel them out. Actually, you reduce them to 1. So 3 ones 3, 3 into 12, 4. And then you cancel out 2 of those a's, or you reduce them to 1. A into A1, A into A1, but you don't write the 1. So what do we have remaining? At the top, we have A by A, that will be A squared, and below, all we have is 4. So we have A squared at the top here, and 4. And that is the answer of simplifying this algebraic fraction. Let's look at another one. Simplify 8a cubed y squared over 4a squared y to the 5th power. I will expand it so again you could see what is happening. 8 multiplied by a 3 times, that is a cubed, multiplied by y 2 times, that is y squared. We will put all of that over 4 a squared y to the 5th. 4 a squared y to the 5th. And then we will reduce, or as you say, cancel. So 4 ones 4, and 4 twos 8. Let's look at the a's. We have one a there with one down here, another one there with another one down there. We don't have any more below. So let's go to the y. We have a y there and another one here, and then one there and one there. And that is about all that we can cancel out or reduce. So what do we have remaining? We have a 2 up there and an a, and we have y cubed down here. So we have 2a, which is that, over y cubed. Now you can leave it like that, but sometimes it's more convenient to take that y cubed and put it on the same line next to that a. And so it becomes 2ay to the negative 3 power. 4/9 and 2/3 plus, if you were to add those, as I said, this is what you would do. And then you would say 6 and 4, 10 over 9, and make that into a mixed number, since right now it is an improper fraction, and you get 1 and 1/9. That is what you do with numbers, no symbols. Let's now apply these principles to algebraic fractions. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. So let's look at a parallel situation here. 4 and 4a over 9 and 9. 2 over here and 2b over here over 3 and 3. They are very similar to what we just did, except that now you have an a here and you have a b here. So how do we go about doing that? Now let's see what we did over here. Let's say we have to add them. Draw a line here and you will get the LCM. In a similar way, we draw a line here and we will get the LCM. 9 and 3, the LCM is 9. 9 and 3, the LCM is 9. And you follow the same procedure that you would do over here. 9 into 9, 1. 1 times 4 is 4. Over here, 9 into 9, 1. 1 times 4a, and you write it like this. 1 times 4a. Of course, it is still 4a. Bring down the addition sign, and then 3 into 9 would be 3. 3 2s, 6. Over here. Over on the right here, 3 into 9, 3. 3 multiplied by 2b, and you write it like that. 3 multiplied by 2b. And then we will simplify it. As I said, over here, you would add that 6 and 4, you get 10. Over here, this is 4a plus 3 to 6b over 9. You can reduce that 10 over 9 to 1 and 1/9. But over on the right here, 4a plus 6b. So 4 apples plus 6 bananas. We can't add the 4a and 6b. So all we could do is rewrite it as 4a plus 6b over 9. That's example 1 of addition and subtraction. You would do it the same way. Of course, this is just an addition. But if you had a subtraction there, you would follow the same procedure. Example 2, simplify. 4a over 4 plus a plus 2 over 6 minus 3 plus a over 3. Now, of course, this first one here, really, if you look at it, it's really a, because that 4 can cancel out that 4. But we will work it as is. Let's find the LCM. 4, 6, and 3. LCM is 12. 4 into 12. 3. 3 times 4a. We write that down here. Plus 6 into 12, 2. 2 times a plus 2, which is this. 2 times a plus 2. Bring down that minus sign here. 3 into 12, 4. 4 times a plus 3. And now we will simplify what is above that line with the LCM. So we get 3 times 4a is 12a plus 2 times a plus 2. Remember the distributive law. You get 2a plus 4 minus 4 times a plus 3, which gives us 4a minus 12. Now we can see if we can simplify anything here. You have 12a plus 2a minus 4a. Those are the a's. And let's deal with the numerals, which is plus 4 minus 12. So we can simplify those a's there, and then we can simplify this. So if we do that, we get 10a minus 8 over 12, and we could further reduce this here by using 2, which gives us 5a minus 4 over 6. And that is about as far as we could go with this. Example 3, still on addition and subtraction. Simplify 7 over 8a, now the denominator has the symbol, minus 3 over 4a plus 5 over 2a. We have to do that. So we need to find the LCM. 8a, 4a, and 2a. A is common, and you could see that there is 8, 4 could go into 8, 2 could go into 8, so your LCM is 8a. Now, that 8a up there into this 8a here will give you 1. 1 times 7 will give you this here, which will actually be 7, minus 4a into 8a is 2. 2 times that 3 up there, you could write it like this, plus 2a into 8a is 4. 4 times that 5, of course, will be 4 times 5. Now let's simplify what is up here above that line. We get 8a is the LCM, 7 minus 6 plus 20. Simplify this. 7 minus 6 is 1 plus 20, that would be 21 over 8a. And that is our answer, 21 over 8a. That was example 3. Example 4, simplify. We are still on addition and subtraction. 7 over 5a minus 3b over 4a plus 5 over 2a. We get our LCM. 5, 4, and 2. The LCM there for the 5, 4, and 2 would be 20, and of course you still have the a to deal with. So that's 20a. Now 5a into 20a is 4, 4 times 7, minus 4a into 20a is 5, 5 times 3b, 5 times 3b, plus 2a into 20a is 10, and then 10 times 5. So let's work out this part on the top here. 4 7's 28 minus 5 3's 15b plus 50. We deal with the numbers first, or separate. We don't have any other b to deal with that up there. So 28 plus 50 minus 15b. We simplify this, and we get 78 minus 15b over 2a. That is our answer. We cannot simplify it any further. Example 5, simplify. 8m minus 3n over 5 minus 3m minus 2n over 10 plus 5n minus 3b over 4. Same procedure. Find the LCM for the denominators. 5, 10, and 4, which will give us 20. 5 into 20 would be 4, and then you take that 4 and multiply everything on the top there. So you get this. This minus here is this one down here. 10 into 20 is 2. Then take that 2 and multiply everything up there. 2 times 3m minus 2n plus 4 into 20 is 5. Take that 5 and multiply everything up here. So you get this. Now let's use that distributive law and simplify what is up here. So 4 8s 32m times 4 3s 12, negative 12, minus 2 times 3m would give you 6m. This negative and that negative would give us a positive, so we get plus 4n, and then that plus there, 5 5 is 25n minus 15b. That is to say, plus 5 multiplied by negative 3. Now we could see if we have like terms. 32m minus 6m, 4n plus 29. That should be 25. 4n plus 25n. And then the b's, negative 15b by itself, there's only one b, and negative 12. So 32 minus 6 will be 26m. 4n plus 25m. 4n plus 25n will give us, that is 20, that's 29, 29n minus 15b minus 12. And that is as far as we could go with that. Remember, this here is 29. All of that over 20. And that should suffice for addition and subtraction of algebraic fractions. We now move to multiplication and division of algebraic fractions. Review of objective 1, 3, 4 over 5 multiplied by 3 over 10 divided by 3 over 4. You rewrite that and invert this after converting that division to a multiplication. And you reduce 3 into 3, 3, and so on. 2 into 4, 2, 2 into 10, 5. And that's about it. So you get 2 times 4 to give us 8, and 5 times 5, 25. The answer to that is 8 over 25. We follow the same procedure with algebraic fraction. Here is example 1 on multiplication and division. 4 fifths multiplied by 2a squared over 10 divide by 12a to the 4th b squared over 20. So we will change this division to multiplication and invert this term on the right. I will expand it so you could see what is happening. 4a over 5, that is this, 2 2's 4a over 5, multiply by 2a squared, that's that, over 10, 2 5's 10, multiply by 20, which is 2 times 2 times 5, over 12, which is 2 times 2 times 3, a to the 4th power, which is a 4 times, and b squared. So let's reduce. That 2 there with the 2 down here, that other 2 there with another 2 here, that 2 there with another 2 here, this 5 down here with that 5 up there, this a here with an a down here, and then you have 2 more a here. So you are finished with all the a's. Anything else can reduce? No. So what are we left with? We are left with this 2 by 2, and then 5 times 3 times a times b squared. So 4 over 5 3 is 15, ab squared. As you learn this a little better, these expansions that I just did up here will not be needed. Example 2, multiplication and division, simplify. You have that fraction there, multiply by this fraction here, multiply by that algebraic fraction. So you have to follow a number of steps. Instead of expanding each term, first we will reduce just the coefficient, the symbols. Just deal with the numbers you see here. That 11 into that 22 goes 2 times. This 5 into that 15 goes 3 times. That 2 there would reduce that 2 there. And this 3 here would reduce that 3 there. So we have dealt with the coefficients. Now we will combine the indices of like symbols, the rule for index multiplication. All the numerators and all the denominators separated. So up here, you have a q squared and a q to the first power. That will give you q cubed. Then you have a y to the first power here and a y to the third power here. That will give you y fourth. Then you have an a squared here alone. So you write back the a squared. And you have a b here by itself. So you write back the b. That is what happens with all the numerators. Let's deal with the denominators now. Let's deal with the q. There's a q here by itself. Write it back. Y, there's a y square here by itself. Write it back. A to the fourth power, that is to say there's an a cube here and an a to the first power here. That becomes a to the fourth power. And then b squared out here. You write back that b squared. And there is a c here. You write that now. So what do we do now? We deal with the indices of like symbols using the rule for index division. So we are going to divide now like terms above by like terms below. So that q, one of that q can be removed from one of this q here, and you're left with q squared. You do the same thing with a y squared from y fourth, you're left with y squared. And now this is the other way around. The 2 is in the numerator and the 4 is at the denominator. So you get the 2, you get an a squared below. Same thing goes for b here. 1b there, 2b on here. So you get b to the first power, and of course c remains down here. So what do we have at the top there? We have q to the fourth power. We have y to the second power. That's it. And what do we have below here? We have a to the second power. We have b to the first power. And we have c to the first power. That is all that remains. Now we could tidy this up a little. And this is our answer to the question we had up here. Example 3, simplify. This fraction, divide by that one. So you know we will change the division to a multiplication and invert the fraction immediately to the right of the division sign, or what used to be the division sign. So we write back this fraction here, change this division to a multiplication, and invert this fraction here on the right. That is this algebraic fraction. So we rewrite it like that. So as I said, let's reduce the coefficients first. That 7 would go into that 14 2 times. That 9 would go into this 27 3 times. And that's all we could do for coefficients. So what are we left with? We are left with 3 times a squared times b times c to the fourth power times d to the third power, d to the third power, all of that over 2 times a, that's that a, this b cubed, that's c, and this b. So this a and that a, you are going to get 1 remaining there. This b up here with this b down here, you are going to get b squared down here. This c with that c fourth, you are going to get c cubed up here. And this d to the first power into d to the third power, you are going to get a square up here. So let's see what we have now. 3a c cubed d squared over 2b squared. That's about it. So your answer is this: 3a c cubed d squared over 2b squared. That is the answer we got when we simplified this, or when we do that division. Example 4, simplify. We are still on multiplication and division. This fraction, this algebraic fraction, multiply by that one, divide by this one. So by now you know what to do. We will change that to multiplication and invert this last one on the right of that division sign. So that's the same fraction up there, multiply by the same fraction up here, multiply by, and we invert this. 15y is now below as the denominator, and 3c squared is the numerator. So let's deal with the coefficients first. 3 here into 15 here, we get 5. That 3 there into 6 over here, we get 2. That 5 over there, with this 5 here, get rid of that, becomes 1. That is as far as we can go. So let's now deal with all the numerator and all the denominators, because we are multiplying them. So we have z cubed y squared, we have an a here, and we have a c squared here. That is all we have as numerators. Denominators, we have a 2 here multiplied by a 2 there, which would give us 4. We have a squared here. We have c cubed there. We have z here. We have y cubed here times y to the first power, which would give us y to the fourth power. So we have multiplied all the numerators and we have multiplied all the denominators after we have reduced the coefficients. Now we will use index division to reduce the same symbol that is in the numerator with 1 in the denominator. So there is a z here and there's a z cubed there. That would make a z squared. There's a y squared up here and a y fourth down here. So we'll get a y squared down here. There's an a up there and an a squared down here. So we'll get an a to the first power. And there is a c squared up there and a c cubed down here. So we'll get a c to the first power. Now let's see what that leaves us with. We have a z squared there. We don't have any y squared there. We don't have anything else up there. Down here we have a 4. We have a to the first power, which is a. We have a c to the first power, which is c. And we have a y to the second power, y squared. So when we simplify that multiplication division up there, this is the answer we get. Z squared over 4ac y squared. That was example 4. Example 5, multiplication and division. For this example, we will just exchange the operators of the last example we did. Where we had division, we will put multiplication, and where we had multiplication, we will put division. So that's the fraction. Divide by this fraction now. Previously, we had multiplication here. Now we have division. And previously, we had division here. Now we have multiplication. So what do? We have to be very careful here, because some students think that once you have this division here, you invert everything to the right of the division. No, you just invert the fraction that is immediately to the right of the division. We will change the division to multiplication and then invert that fraction immediately to the right of the division only for what used to be the division. So we get this fraction here, multiply by this one inverted, multiply by this one as is. The only way you would invert this is if you had those last two fractions in brackets like that. Then you would invert both of them, but you don't have both of them in brackets. So we will work the way we are going here. So let's deal with coefficients first. This 3 with that 15 up there, you get 5. Then that 2 up there with this 6 down here, you get 3. And that's about it. So now we will combine the indices of each symbol above and then below, and we will use the index rule for multiplication. So what do we have above? We have 5 times 5, which is 25. We have a z cube and a z to the first power, which would give us z to the fourth power. And we have a y squared, a y cubed, and a y to the first power. Add up all those indices, and we get y to the sixth power. Let's go below. 3 times 3, that will give us 9. A squared times a to the first power to give us a cubed. And then we have a c cubed here and a c squared here, which would give us c to the fifth power. Now we will deal with the indices of each symbol above in relation to those below, which is index division. Well, the thing about it is we don't have any two common symbol here. So we just write that back as is. 25 z to the fourth, y to the sixth over 9 a cubed c to the fifth power. So we just did objective 8, simplify algebraic fractions. And that brings us to the end of video 8 based on objective 8 in section 6.